Hello students, welcome to Magesh classes. In this presentation we are going to discuss about Neet 2020 Phase 2 Chemistry questions. It is a Neet Booster videos 2. In this video, I would like to discuss about the questions from 6 to 10. Let's move into the question part. Question number 6. Which of the following will not undergo SN1 reaction with the OH ion? So it is a hydrolysis in the presence of base. Which of the following will not undergo SN1 reaction? The concept is, in general, the nucleophilic substitution reaction SN2 and SN1. There are two types. One more type SNI is there. Here SN2 and SN1. The comparison is, in case of SN2, it is always given by the primary halides. And in case of SN1 type, is given by tertiary halides. So here the question is, the following will not give SN1 type. So the tertiary halide only gives SN1. The primary halide does not give SN1. Here the CCl, it is a tertiary. So here it undergoes SN1 type. And the CH2Cl, it is a primary, and it is a primary, and it is also a primary. So the complication is three primary halides are present. Which one does not give this SN1 type? Okay. So in case of CH2Cl, the first one A, the benzyl chloride. The benzyl chloride, by means of, if it is involves in the SN1 type, what happens? The carbocation is formed. This carbocation is not stabilized by resonance. Okay, so this the positive ions moves here and there. So this is because of resonance, it is more stable. So this type of halide, even though it is a primary halide, it undergoes SN1 type. Okay, and the B, in case of B, it is a CH2 allyl halide. This forms a carbocation, allyl carbocation. It is also established by resonance, and so it involves the SN1 type. So in SN1 type, the intermediate is a carbocation. If the carbocation is stabilized, the reaction is possible. So by means of benzyl, it is a resonance stabilized, and the allyl carbocation is stabilized. See the D. Here the carbocation is CH2 plus. This carbocation cannot be stabilized by resonance because here the carbon side chain is present. There is no shifting of positive ions and the resonance, and so this compound does not give SN1 type. It gives only the SN2 type. Okay, clear? So your answer is D. D is the compound that does not undergo SN1 type reaction. Clear? Question number 7. A reaction of propanamide with ethanolic sodium hydroxide and bromine will give. What is the concept? The ethanolic sodium hydroxide and bromine is the combination in the Hoffman degradation reaction. Hoffman degradation. What is this Hoffman degradation reaction? The amide compound is converted into amine compound. Here the reagent is alcoholic sodium hydroxide and bromine. It's a catalyst. It is the alcoholic sodium hydroxide. And what is the concept? The amide is converted into amine. Here one carbon is less than that of the parent amide. Okay. So propanamide is the starting material. Propanamide contains 3 carbon atoms, CH2, CO, NH2. So this is the propanamide. Okay. When it is treated with the sodium hydroxide and bromine. So it is alcoholic sodium hydroxide. What happens? The product is nothing. It is amine with 1 carbon less. Here the 2 carbon, here the 3 carbon. So the product is aniline is the aromatic compound, and the ethylamine is the answer. Methylamine consists of only 1 carbon. Here it is 2 carbon, and the propylamine consists of 3 carbon. So it is not the answer. It is not the answer. So this is the answer. Clear? Question number 8. In which of the salts the colloidal particles are with negative charge? The concept is, colloidal solution, the charge is calculated by the concept electrophoresis. When the colloidal solution is placed in the electric field, depending upon the type of charge of the colloidal particles, it moves towards a particular electrode. Move towards cathode or anode depending upon the charge. So it is a experimental data. In hydrated alumina is Al2O3 XH2O. Due to the presence of Al3 plus ion, it is positive in charge. And titanium oxide, it has titanium 4 plus ion, it is positive in charge. So it is a experimental data. And hemoglobin, it is given that it is positive colloid, and the starch is only the negative colloids. The charge of the colloidal solution can be calculated by means of electrophoresis. The electrophoresis techniques gives the charge of the dispersed phase, that is a colloidal particle, and the dispersion medium is followed by the electroosmosis. Electroosmosis gives the dispersion medium. Electrophoresis gives dispersed phase. Okay. By two methods, you can find out the charge of the colloidal particles. Charge having the negative colloid. So this is the answer. Question number 9. The minimum pressure required to compress the 600 decimeter cube of a gas, that is 600 liter of a gas at 1 bar, to 150 decimeter cube, 150 liter at 40 degrees Celsius. At constant temperature, according to Boyle's law, the PV is constant. So PV is constant at constant temperature. It is Boyle's law. So P1 V1 is constant. So you can write P1 V1 is equal to P2 V2. Here the one system consists of 1 bar pressure, that is 1 bar, and the 600 decimeter cube. The same system is compressed to another volume, that is 150 decimeter cube, and what is the pressure at that time? So here the P2 is equal to 1 into 600 divided by 150. So this is 6 bar. The answer is B. So it is simple concept. It is based on the Boyle's law. Boyle's law is P1 V1 is equal to P2 V2. So we can find out the three values are given. You can find out another value at constant temperature. It is very important. At 40 degrees Celsius, the P1 V1 is equal to P2 V2. Clear? Question number 10. The number of angular nodes and radial nodes in 3s orbitals are. What is the concept? To find out the nodes, the orbital consists of nodes. There are two types of nodes. One is the angular nodes. Angular nodes is given by the azimuthal quantum number L. And the radial nodes are given by the formula n minus L minus 1. Okay, so this is a formula to find out the nodes. Nodes is a point or this space in which the probability of finding the electron is 0. That is the probability of finding the electron is given by psi squared. The value is 0. So nodes is here the electron density is equal to 0. So how many angular nodes are present and how many radial nodes are present? For 3s orbitals, it is n value and it is L value. Okay, the n value is 3 and the L value for s is equal to 0. Here the s is equal to 0, p orbital it is 1, d orbital is 2, and the f orbital 3 for the quantum numbers values for the azimuthal quantum number. For 3s orbital, n value is 3. So angular node that is L is given by 0. So angular azimuthal quantum number, the value is 0. And the radial nodes are obtained by the formula 3 minus L value is 0 and minus. There is n minus L minus 1. So it is 2. So radial nodes 2 and angular nodes 0. So angular nodes and radial nodes are 0 and 2 respectively. So our answer is B. Okay students, we have come to the end of the session. After this we have stopped. We will continue in the next videos. If this video is useful to you, don't forget to subscribe this channel. Thank you for listening.